Okay, so we didn't finish our notes in class. I'm going to skip to the second page where we left off in class, and then I'll go back and fill in the first page for anyone that needs that, if they were absent or whatnot. So, all right, so now we are back to the rule or postulate. So I'm not sure how this records. I don't know if by going back, if it's just going to start my recording from the beginning, so it wasn't supposed to. I don't know if that's what happened. I guess we'll find out shortly. So the rule or postulate basically says that the difference between any 2 points equals the absolute value of the distance between the coordinates. I know it's very wordy. The distance between 2 points equals the absolute value of the difference between the coordinates. So basically, I had the AB thing, but I'll give you guys an actual example. If you wanted to know the distance between negative 100 to 218, okay, you don't want to count on a number line. That would be crazy. So here we have A and here we have B, and they are at negative 100 way over here, and all the way to the right is 218. Well, instead of counting, all it is the absolute value of A minus B. So do that. Negative 100 minus 218 gives me absolute value of negative 318, which essentially is just 318. So it's 318 spaces between A and B. And that's all they're telling you to do. Because all absolute value is for each number is the distance from 0. So absolute value of 100 would be 100, and absolute value of 218 would be 218. So put those together and you have 318. Okay, moving on. Congruent segments, 2 segments with the same length. So this is, the shape is the same. So we say if AB segment is equal to the length of CD segment, then here's another conditional. Segment AB is congruent to segment CD. And I talked in class about the importance of when you use an equal sign without the little mark above, and when you use a congruent sign with the mark above. So that can get confusing. So go slow and think about it. All right, and then piggybacking on that, the statement AB is congruent to CD is okay, and they're interchangeable. So you can use these in whatever sentence you want because they're correct notation. However, you cannot combine them. I'm trying to go fast because the bell's about to ring. So, however, AB equals CD is not okay. You can't use the segment symbol with an equal sign, okay? Next slide. And this is where we left off, the segment addition postulate. So with the segment addition postulate, basically, it's exactly what the name says. You're adding segments together. And it says if you have 3 points, we'll call them A, B, and C, and they're collinear, and the B number is between A and C, that's my shorthand for between. Then if you added the length of segment AB, in the segment BC, you would get the entire distance from point A all the way to point C. It's common sense, but they had a postulate for it. This, just so you guys know, in Chapter 2 we're going to start talking about conditionals, and I just want to point out so that you're familiar when we get there. The whole sentence here, if 3 points, yada, 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 then AB plus BC equals AC, that's called a conditional or an if-then statement. You're going to see a lot of that when we do postulates and theorems. If something is true, then something will be true as well, that type of thing. All right, so if we drew a picture of that, we have point A here, and point C, and B is someplace in between. I think we can all agree that the distance from A to B plus the distance from B to C would be the same distance as A to C. Guess this is similar to saying just because you go from school to your house and say there's a store on the way where you don't got to go out of your way, you can just stop on the way, and you stop at the store and then go home, it's the same distance, regardless if you stop in the middle or if you don't. All right, example 2. If segment AB is 25 units long, find the value of x. Then find AN's length and NB's length. So now we're going to get into this segment addition postulate using expressions with variables. So when we do this, let's just start with labeling. It is extremely important that you guys label your pictures with the given information. So it tells us AB is 25. Let's fill that in. Let's draw a little loop here, and let's label this 25. Because if you don't label it, you're going to forget. All right, and find the value of x. Well, we've created an equation here without physically writing it out, so the next step would be to actually write it out. So you would write, well, this segment AN plus this segment AB equals the segment from A to B. We just discussed that when we talked about the segment addition postulate. So we need to write that out with these expressions. So I have 2x minus 6 right here, plus, because we're adding two distances together, x plus 7, and that equals the entire distance 25. See, now if you wouldn't have wrote this 25 out, for many people this is just words read. They don't do anything with it, so it's important. Any words that they give you, generally you're going to use. It's very seldom that they give you information that you don't use, so be careful. So we're going to go ahead and combine our like terms. I have 2x's here and 1x here. That gives me a total of 3x's. And I can combine my -6 with my 7, and that would give me a 1 equals 25. I got to get x by itself, so I need to subtract 1, so that becomes a 0. And whatever I do to one side, I have to do to another. So those are gone. So I have 3x equals 24. And then I can I need x to be a 1x, so to get that 3 to become a 1, I have to divide by itself. Whatever I do to one side, I have to do to the other. So I get x equals 8. So x's value is 8. This is another big thing with the geometry questions. Here's one question, and here are two others. We now need to plug back in 8 into an. So if I plug in my 8 and I get 2 times 8 minus 6, that's 16 minus 6, so that's 10. So from A to N is 10 units long. And then if I plug in an 8 here, 8 plus 7 is 15. And N to B is 15 units long. And those are our answers for that question. Now midpoint, hopefully everyone knows what a midpoint is. Basically, it's just a point that divides a segment into two congruent segments. So it's a point in the middle of a segment. So a point that divides, because this is the official definition, the segment into two congruent segments. 2, there's our congruent symbol, segments. It'll be really beneficial to you if you start using shorthand, since there's so many symbols in geometry. It'll save you time, and it'll help familiarize yourself with all the symbols so that you, when you're asked a question with symbols, you know what it means. Now bisecting, similar to midpoint, it is to actually cut the segment into two equal parts. The midpoint is where you would cut, and bisecting is actually cutting it. So to cut a segment or angle, because next section we'll be doing angles, into two equal parts. All right, so now we'll do a couple examples and we will be done with that. All right, so M is the midpoint of RT, segment RT. Find RM, MT, and RT. Now, like I said before, there's some important information in here. If you just look at the picture and look at that, you don't know that M is the middle. You could assume based on the drawing, but a lot of drawings look like they're in the middle, and they're really not when you do the math, and sometimes they don't look like they're in the middle, but they really are. So you always have to read the directions. This is an extremely important word because it allows us to put an equal sign right there. Sometimes you'll have to add those, like in that previous example. So by having that word midpoint, I can create my equation. I can say 5x plus 9 equals 8x minus 36. So from there, I get x's on one side, so I'm going to just subtract the smaller x so it goes over and gets it off of that side. So then I have 3x minus 36. I need to get the x by itself, so I have to make that negative 36 a 0, and I can do that by adding the opposite. So add 35. So I get 3x. Oh, sorry, add 36, not 35. I don't know what I'm thinking. So add the 36 to the 9, and I get 45. And then divide by the 3, because I need it to be a 1x. So x equals, oh, what does x equal? 15. So now I have x's value, but if you notice up here, it doesn't ask me what x is. So if you just leave it like this, basically you've done a lot of work for no points. So make sure you answer the question. I'll say that a lot because it happens often. So RM, well, here's R to M. They want to know how long that is. We're going to find that out by using substitution. We're going to take this 15 and plug it in for that x. So I end up getting 5 times 15 plus 9. If I do all that, I'll end up with 84. Now here's the thing. You know that technically m to t should also be 84, but it's not going to hurt anybody if you double check, because maybe if it's not, then you did something wrong. So just for the sake of checking, I'm going to do 8 times the 15, because that's what x is, minus 36, and I get 84. So I'm good to go, but it doesn't hurt to check. And last but not least, because still, if you're not done, you still have to do RT. So all the way to RT, I think you can do this one all on your own, but just in case, R to T is all the way across. Hopefully you gather that it's 84 plus 84, and you end up with 168. So RT equals 168. So make sure you label your pictures, you create your equation, you solve the equation, and then you answer the correct question. Sometimes you get so bogged down into finding the variable's value that you forget that that wasn't even what they asked. You just needed that in order to answer the question asked. Okay, so that was the end of the notes. Tomorrow we're going to work on page 33. So if you're bored tonight, the weather's not looking so hot, you guys can start doing that. And if you have any questions, feel free to email me. I will be happy to answer you. I do have one little change though. This should be 37, not 35. And this should be 52, not 48. Okay. All right, have a good night. Now I'm going to go back and I'm going to do the other one, okay? So from here, if you're good, then you don't have to worry about it, but I'm going to flip back to the previous slide.